This is a video about building simple mathematical models. We know from Newton's second law of motion that force is equal to mass times acceleration. Let's have a cell called force, and we set that equal to 1 Newton, and we have a cell called mass, and we set that equal to 1 kilogram, and we can calculate the acceleration, which is equal to the force divided by the mass in meters per second squared. So if we double the force, we double the acceleration, and if we double the mass, we halve the acceleration. So we now have a very simple model that calculates Newton's second law of motion for us. Now imagine this was applied to a rocket that was burning fuel as it accelerated, which means that the mass at takeoff is constantly decreasing. So as the mass decreases, we'd expect the acceleration to increase, which means that instead of calculating it from force and mass, we now need to introduce time as a factor. So let's do that. Let's move this label to here. We'll have a label called time. Time will start at time equals 0 and will go up in increments of 1 second, which means that the time in this cell is equal to the time in the previous cell plus 1. We need an additional variable called burn rate, and we'll set that equal to 1 kilogram per second. Now, the acceleration is equal to the force divided by the mass at takeoff minus the burn rate times the time. And if the mass at takeoff is 10 kilograms, then the acceleration is going to be 0.1 meters per second squared. We want to copy this cell into a table, but before we do that we need a trick to make sure that values stay constant. The force is always in cell C3, so I need to put $1 there to keep the 3 constant. The takeoff mass is always in C4, and I need $1 there to keep that constant, and the burn rate for our purposes will be constant, so I need $1 there as well. The time is in cell A8 now, and it will be A9, then A10, and so on. If I now copy this cell by picking up the bottom right hand corner and dragging it down 1, I've now got the acceleration after 1 second. So if I mark these two cells and drag that down to 18 seconds, which is when our mass goes to 0. For tidiness, let's just format these cells. And we can see that the acceleration increases all the way to infinity when we have no mass left. So now if we mark this block and say insert chart, we now get a graph of our acceleration up to 1 meter per second squared. And if we increase the force, we increase the acceleration. If we decrease the force, we decrease the acceleration, and each time we can see what our maximum acceleration is going to be. So to review our simple model, we've got a block for the input, we've got a table for our calculations, and we have a graph that shows us the output. We can now test what if by changing our inputs, Our calculations will work out the effect of that, and our graph will display that effect. And that's how you build a simple mathematical model.